STP or spanning tree protocol. In this video, I'm going to talk about again spanning tree protocol, the most important and maybe the most famous LAN protocol. You know that in previous video we talked about the STP, and now we can understand the basic and fundamental process in STP. You know that in STP first we should elect a root bridge. Electing root bridge is the first step. The second step is selecting root ports in all of the switches, and the third step is selecting designated port in all of the, for example, links. After that, we need to convert to forward state all of the root and also designated ports, and finally other ports are the block or alternate ports, and the state of them are block. You know it, and you experienced this process before. Now I'm going to talk about some more detailed information about the STP. First, let me start with the topic we call it STP tiebreakers. Okay, let me to solve some for example examples. After that you will better learn the STP tiebreakers. Okay, we have here three scenario. Let me start from the first scenario, the left scenario. You can understand what is the usage of the STP tie breakers. In this scenario, we have four switches: switch 1, switch 2, switch 3, and switch 4. They are connected to each other with 1 gigabit per second link. And also, as you can see, we have the MAC 1 has a lower value than MAC 2, has a lower value than MAC 3, and also than MAC 4. Okay, because of that, now we need to find the roles of the interfaces. You know that first we should find the roles of the interfaces. After that, we can identify the block and forward ports. Here, the switch 1 is the root bridge. Why? Because the BID of the switch 1 has a lower or lowest value. You know that the BID include two parts: priority and then the MAC address of the switch. Because the MAC 1 has lower value than other MAC address, and because the priority between these four switches are same, the switch 1 is the root bridge. So easy. Let me to go to the next step, the second step, selecting root ports. Okay, for selecting root ports, we need to find the cost of the interfaces to reaching to the, for example, root bridge. Here in switch 2 we have two ports, port 1 and port 2. The cost of port 1 to reach to the root bridge is the 4. You know that the 1 gigabit per second link has cost of 4, and here we have 1 gigabit per second link. Because of that, from port 2 we have cost of 12. Okay, 4, 4, 4, and then we can say now the port 1 is the root port. So easy. Also in the switch 3 we have the same condition. Port 1 has cost of 4 and port 2 has cost of 12, as you can see. Because of that, the port 1 is the root port of the switch 3. So easy. Let me to find the root port of the switch 4. In switch 4, as you can see, we have two ports, port 1 and port 2, and the cost of port 1 is 8, because we have 1 gigabit per second link and total cost is 8 for this port, and also for the port 2 we have again the cost of 8. This means that now we are experiencing a tie to finding the root port. Okay, because the cost of both links are same. Here we need to use the tiebreakers. What is a tiebreaker? When you can't find from the three-step rules, for example, role of the ports, you need to use the tiebreakers. The first tiebreaker is the lowest sender bridge ID. Okay, lowest sender or lowest sender bridge ID. Okay, sender bridge ID. I will explain it. You can easily understand it. Lower or lowest in bridge ID. Look at here. When two interface, okay, are experiencing the same total cost to the root bridge, you can use the first tiebreaker. Okay, this means that for finding the root port, you need to find which port connected to a bridge with the lower bridge ID. You know that the bridge ID of the switch 2 is BID2. Okay, include the for example 32,768 colon MAC 2. This is the BID of the switch 2, and also this port 2 of switch 4 connected to the switch 3 with the BID 3 and equal to this value. And now the rule is when the two ports are using the or are experiencing the same cost, you need to find the port 1 connected to which switch and port 2 connected to another switch. And after that, each switch, each of them that has lower cost, okay, the port that connected to that switch is the root port. For example, here you know that the MAC2 has a lower value of the MAC3, and because of that the port connected to switch 2 is the root port. So easy. This is the first tiebreaker. Because of that, now with usage of this tiebreaker we are finding the root port. Don't forget that only when you are experiencing a tie you can use the tiebreakers. Okay, here I used the first tiebreaker for finding the root port. Now we found all of the root port. Now we need to find the for example designated ports, the second step. For designated port we can say that all of the interfaces of the root bridge are designated port. It's okay, designated port, and then in this link this interface is designated port, and the link between the switch 2 and switch 4. First, the port 2 of the switch 2 has cost of 4 to root bridge, and the port 1 of switch 4, the switch 4 has cost of 8. Because of that we can say this interface is the designated port. Okay, you know that in each link we have two for example side. Each side has a cost to the root bridge, and after that the lowest cost or the lower cost is the designated port. After that, between the switch 3 and switch 4, again we have one link. The link connected to switch 3, the interface connected to switch 3 has lower cost to the root bridge. In sometimes we can say the switch 3 and switch 4, between them the switch 3 is designated switch and the port of the switch 3 is designated port. Okay, and now as you can see we found all of the root ports in all three switches, because the switch 1 doesn't have the root port, it is root bridge. And also we found all of the designated ports in all links. In one network you have for example you can find the root port in all switch except the root bridge, but in each link you need to find one designated port. So easy. And you know that this is the alternate port, okay, because this is not the root port and neither the designated port. Let me to write here ALTN, or the alternate port. So easy. Okay, this is the first scenario. Let me to show you the second scenario. This is the second scenario. In this scenario we have only two switch 5 and switch 6, and the MAC 5 has a less value or lower value than the MAC 6. Okay, first we need to find the root bridge. You know that the switch 5 is the root bridge. Why? Because the switch 5 has less value in for example in the lower value in the MAC and also in the bridge ID. Then we need to find the root port in switch 6. Look at here, in switch 6 we have two ports. Each of these ports has a cost of 4 to the root bridge. Because of that we need to use the tiebreaker. Okay, the first tiebreaker is lower sender bridge ID. This means you need to find the port 2 connected to which port, and port 1 to which switch, and port 1 connected to for example which switch, and after that you need to compare the MAC address or the BID of that two switch. But here both of switch port 1 and port 2 are connecting to one switch. Because of that the first tiebreaker cannot help us. We need another tiebreaker. Okay, let me to talk about another tiebreaker. This is the next tiebreaker, lower or lowest, okay, sender port ID. Okay, sender port ID. What is the port ID? You know the bridge ID, but you don't know about the port ID because I didn't explain the port ID. First, let me define the port ID. You know that in each switch we for each switch we have a bridge ID with this formula: priority plus system and system ID. We call it the MAC address. System ID is the MAC address. Okay, priority system ID. System ID is a unique identifier system with 6-byte length, and this is the MAC address. You know that this is original format of bridge ID. But also we have another definition. We call it the port ID. What is the port ID? Each interface, for example, interface facet and a 01 has a port ID. Okay, we call it PID or port ID. And again, here we have a formula. First, port priority, okay, port priority, then colon